Section 2.3, we're going to be talking about reflections. And again, this is another little easy concept. A reflection basically takes a figure and flips it based upon what's called a line of reflection. I know that's a lot of redundancy in that definition, but it's pretty much this. It makes a mirror image. All right, pretty easy. There is a symbol that I want you to be aware of, and it's basically like a little apostrophe. Depending on what you're doing, this symbol can be used for many different things in mathematics, but in geometry, we're going to just keep it at that. It just represents that two figures are mirror one another. So if I have a triangle ABC, its mirror image would be triangle ABC with the little marks up there. So this is, and I tell you what I would normally read this out as I would read this as A prime, B prime, C prime. You don't really have to know that because it does get a little bit confusing, but just know the little bit of nomenclature there. The reflection of triangle ABC is triangle A prime, B prime, C prime. And that's the way I'm going to say it for now. All right. And again, that kind of depends on kind of who teaches you that and what it's used for, but we're going to call it prime. All right, it's just a little bit easier to read that way. All right, so that's just kind of a thing. Don't worry too much about it though. All right, now going along with this, it's asking whether this is a reflection of that, and this would be my line of reflection. So if there was a mirror right here, does this mirror this? Well, let's see if we can find out to the best. Cool. So we got a little mirror. We can thank Miss Lachlan for this. So if I did a line of reflection and put a mirror there, is that a mirror reflection of this? And as you can see, absolutely not. It is not one. So the answer would be no. So let's try this next one. If we do that, is it the same thing? So yeah, it is. Notice how this is going down towards the bottom here, the bottom of the arrow. Well, the same thing's happening here. So this is a reflection. All right, so the answer with that one be yes. Let's try the next one. This is might be a little bit more difficult, but we'll see. Cool, not too bad. So notice that the bottom here where we see the oval shape is being reflected in the top, and hey, that's the same thing. All right, so yes, that is a reflection. That one's easy. All right, and you don't really need a mirror in this. You can probably get the concept. Whatever's closest to the line of reflection is going to be the closest thing on the other side of the line of reflection. Notice this. This is my original piece. This bottom corner right here is closest to the line of reflection, and so is this one. Let's look at this. This is my original object, and the flat side is closest to my line of reflection. But when we look on the other side, it's a point. So no, that is not going to be a reflection. All right, so let's do this. It says draw a figure and its reflection in the x-axis. Identify the coordinates of the image. So what it's asking me to do is to draw the original. So I'm going to break my own rule this time just so we have a difference of color. I'm going to draw this in ink. It says 1, 2, so I'm going to draw it. The next one is 3, 2, so 3, 2 would be here. And the last one is 1 and 4, 1, 4. So I have that. And let's go ahead and connect that. And somebody has put these all over the ruler and, oh well. So let's go ahead and connect it. All right. And All right. So we know that this happens to be A, this is our B, and this is our C. So it tells me that I'm going to reflect in the x-axis. So if I use my mirror here, I can kind of get an idea of where it is, and it's not the best, but if you look, it gives us a reflection pretty good. And notice how A is going to change into 1 and -2. And so forth, and then B changes into, looks like 3 and -2, and the next one would be 1 and -2. So that's kind of what we see. Now, in case you don't have a mirror, go back to that same concept. You know what a reflection works like. This point is going to be the exact same distance on the other side of the reflection. So let's start with A. It's going to be the exact same distance away, so in the same side. So this would become A prime. B is going to be the exact same distance away from the x-axis. So there's a difference of 2 here, there's a difference of 2 here, so that becomes B prime. And then C will be the exact same distance, which is 4, and this is 4, and that becomes C prime. So we can label it. A prime happens to be 1 and negative 2. B prime happens to be 3 and negative 2. And then C prime happens to be 1 and negative 4. And those are my points. And again, I can just go ahead and draw this out. It's not that big of a deal. And I'm done. All right. Now, let's look at number 6. All right. No, actually, let's do this. Why don't you try 5 on your own? Remember, you're reflecting in the x-axis. All right, so when you got this, here is my original picture, and this would be my reflection, and here are my points for my W prime, X prime, Y prime, and Z prime. Double check yourself, and if you got any questions, you know how to find me. All right, so number 6, same concept. I'm gonna do the same thing. I'm gonna plot these points first. J is at 3 and 4, so we'll put J right here. K is at 3 and 0, so 3 and 0, this would make K. And then I have L at 2 and 4, which would be 2 and 4, yep, right here. And that would make my L. Draw my lines. Okay. And we have it. We have our picture. So for this one, after we plot the points, we can basically check our mirror, and sorry for my hand being in the way, I'll do the best we can. It'll look something similar to this when we're done. Not the best, but let's go ahead and start looking at our points. Let's work at K. So we know the X will not change, but it's 1, 2, 3 away, so this would become K prime. And now let's look at J. J is going to be on the 4, but it's 1, 2, 3 away. So 1, 2, 3 away. So this would be J prime. And now let's look at L. It's 2 away, so it would be here, and that would be my L prime. All right? And then I can draw my lines as I did a while ago. And just to connect everything out, and my pencil is getting very dull and I don't like it, and I don't have my pencil sharpener with me at the moment, so I'll just do what I got. So let's go with it. My J prime happens to be negative 3 and 4. K prime is going to be negative 3 and 0. Whoops. And then my L prime is going to be negative 2 and 4. All right, so why don't you try 7 on your own? So this should be what you've got. This was your original picture. This is your reflection, and here are your prime points. You can check that yourself. All right, so let's look at 8, and then we'll be done with this information. It says 8, in a pinball game, when you perfectly reflect the ball off the wall, will the ball hit the bonus target? So let's look at it. Here is our ball right here, and we are going to come at this at an angle. And this is actually something that goes into some physics and actually some trigonometry. This is actually pretty cool. But anyway, when we hit the ball, it's going to reflect at the perfect thing. So it reflects off of this. It's going to be a reflection along the x-axis. So notice what we have. We're going to have 1, 2, 3, 4 away from the x-axis. So I have 1, 2, 3, 4 away. Let's do that again. 1, 2, 3, 4 away. I miscounted. So the actual ball is going to hit here. So does it hit the bonus? No, it does not hit the bonus. And that's pretty much it for this video. If you know how to find me, if you got some questions, and as always, come find me if you need me. That was redundant, Mr. Lewis. But anyway, I'll see you in the next video. Bye-bye.